So last week we talked about the conservation of matter and how matter is neither created nor destroyed, but it is able to turn into different forms. And so a good example of this would be like water. So water can be in the liquid form. So for example, you could have a pot of water. And let's say you put it on the stove and you began to boil it. And with heat, with energy, then this can change physical properties and turn into a gas. Now, it's important to realize that water is composed of atoms, hydrogen and oxygen. So H2O, in its liquid form, it forms bonds between water molecules that makes it a liquid. And what we're breaking those bonds, we're breaking the bonds between the water molecules in order to release the water as steam. And so we do not lose mass in that process. So if you left that to boil all day long and you came back and there was no liquid water left, that same amount of mass would be in our atmosphere. So it's important to realize that even if we cannot see it, there are atoms that are found in our atmosphere, and that accounts for the mass. So we do not lose mass when we boil a pot of water down to nothing. It has just changed in its form. So likewise, we can talk about photosynthesis. So this is just an example of conservation of matter. Another example is how plants are able to obtain carbon. So I mentioned that carbon is necessary for the building of carbohydrates. So in plants, when we talk about their skeleton, they use a type of carbohydrate called cellulose. And this is what makes up the cell walls of plants. And it is a very large molecule, and it is a carbohydrate. Interestingly, we cannot digest cellulose, and so we generally think of it as fiber. And it is important because it feeds the microbes in our gut, and it also is important because it keeps things moving through our digestive tract. So it's important that you have fiber, even though you can't obtain energy out of it, but it allows, it is good for your health. Okay, so we can talk about how does a plant go from being like a tree, go from being like a seedling to a huge tree. And where does that mass come from? It is not created out of nothing. And it is not taken from the soil. Otherwise, there would be a big hole. And it is not water that is absorbed up from the roots. So when we look at the chemical formula for photosynthesis, we have 6 carbon dioxide molecules plus 6 water molecules. And I think I've given you this before. But then we have light energy, so sunlight. And that is the energy that is going to allow us to form chemical bonds between the carbon. This is going to produce, C6, H12, O6 plus, okay. So we have taken carbon out of the atmosphere. So that is where the mass comes from when we are growing our garden. Where does that big biomass come from? It's the carbon from the atmosphere. So these should be balanced. So for example, I have 6 carbon atoms on this side, and I have 6 carbon atoms on this side. I have 12 hydrogen, and then the oxygen here, I have 6 oxygen. There's 12 here, but then there's also 12 here. So I have, actually I have 6 here, and then I have 12 here. So I have 18, and that's the same as what is on the other side. So there is no net loss or gain of atoms or matter in this process of photosynthesis. And so we call this process what is referred to as productivity. And this would be the ability to produce new biomass. And so remember that producers, which are autotrophs, which are plants and other photosynthetic organisms, are capable of doing this conversion of matter and energy. But this is another example of the conservation of matter.